Hello, how are you? Good morning, good afternoon, good evening. Let's get our cup of coffee and start. We continue with a series of hacks, videos of hacks, but to solve integral, not exactly of, but yes. Many of these have to do with, very good, in this case. This is the second hack we have for you, and this has arisen of doubts of my students about what happens when we have certain terms that then we have to modify them. We have to change them in order to resolve integral. Such hacks not necessarily are on the subject of integrals, but we do need to know in order to resolve the integral. We could say that these are issues that are supposed to be, or is it knowledge that we are supposed to already have to solve integral? Yes. In this case, this video series is for remind us how to use them, what is done, what is possible, and what is not possible to do, and how to do so. Agree in this particular case. Let's observe what happens when we have a root and what it means. A root, a square root. In this case, we can observe a square root on its own, and we all know that this little house we have there means square root. That's exactly the same as putting this at 1/2. Yes, we are saying that what we have here is this little box that we have within the square root, exactly this little box we have in the parentheses, and but raised to 1/2, we are saying that this root symbol is exactly the same as that 1/2. Agree very well how they could better explain this very well. You may wonder, coding the form of 1/2, why the house equals 1/2? Why? If I have this little house here is integral, why I can put it as 1/2? What does it mean? Y1 and Y2? Very well. This has its meaning, has its reasoning. Let's move on to this other side with another color. The part superior of this fraction, this 1/2, and at the bottom we have 1, 2. Okay, in this case we are going to enlarge this 1/2 to make it clearer. We will have 1/2. Let's put it with another color. This one means the power we have of our purple rectangle or our little purple box. Okay, the power, what is the power of the box? Is this little number that we can have here, or what we have here, which is elevated to 1. Agree, but we do not put it. We know it exists, but we do not put it. And what does 0, 2 mean? That's where it comes from, which is square root. Okay, this is where it comes from. This, and at the top 0, 1. Let's put it in purple. The box refers to the exponent of the box, to this one here. Okay, it is clear. Very good. I will move on to delete very well. Recapturing a little bit, we know that we have a square root of what? From a small box above, and is exactly the same that if we have one box, the same box, we have a power here which is at 1 o'clock, and in the part of the root house we have 1, 2 because it is square root. Okay, very well. Then from there to where we went, and here we can pass again to have a parenthesis, little box inside, and raise to 1/2 truth. Very well. And what would happen? For example, if we had cubic root, we have the little box. Whenever we have a root, we have a little box. Do you agree? Very well. And we would have an exponent in this case if it is not identified with the exponent as some other exponent, such as this be a binomial squared. For example, be a square, a cube to the 4th. By default, we have 1, 1 there. Agree, perfect. This would be the same as what would be the same to put it with color to jump up here, would be equal to having the parentheses and place our little box. And you tell me what would be the fraction that we would put. We would have always, remember, first at the numerator part, there is going to be the power of the little box. We would have 1 between what the root house is worth, 1/3, perfect. And in the case given that we had root to the 4th, for example, 0, 4 here, well, let's suppose we have a little box as well, as we have no other exponent. We have 1, 1 here by default. We are going to put an orange color to go all the way to the end. We would have parentheses and parentheses, and inside in the parentheses we would have the little box above. We close parentheses, and what would then be the numbers of the fraction? We would have 1 who is the exponent of the box between 2, what the root to the 4th is worth, perfect, and what would happen, for example. And finally, if we had cubic root, the x squared, I'm going to put the x in a purple color because it is the little box. Agree, x squared. What is happening here? We would pass to place the part of the parentheses, the little box part. And what would it be like? What is in the numerator? Remember, the numerator part goes what's inside of the root house and the exponent of the box, which would be 2 between 3, 2/3, perfect. In this case, when we come across an integral where we have a root, it is necessary make this process left wing, right to remove a root house and return it to put parentheses, put fraction, and a is worth the exponent because that exponent will. To be able to do it, for example, by the string rule, which is at n plus 1. Agree, then it is necessary to know how much that root is worth in fraction. Agree, yes. Or it is not necessarily a fraction, but the value of a root leads to a fraction of, and it is possible to add 1 to that fraction for the chain rule. For example, yes, or to be able to derive it at the time. Agree in this case. This would be the second hack or the second tip to solve integral, which, as you have seen, is not a full issue of integrals, but it is knowledge we need in order to solve perfect. Take care of yourselves. See you next time. See you in the next hack. Have a great week. Drink lots of coffee. See you at the next one. Thank you very much.